Well, good morning, good evening, good afternoon, wherever you may be, anywhere across the world. Thanks so much for joining us here live on what is obviously serverless office hours. So thanks so much for joining us. If you're here via the AWS Twitch channel, welcome, via YouTube Serverless LAN channel, and also via LinkedIn Live. Happy to have you. My name's Julian Wood. I'm a senior developer advocate for serverless here at AWS, and I'm super happy to be joined by Osama Nasim, who's a product manager for MSK Serverless. Osama, how are you today? My brain is getting all the wrong way around. I had a note down of your name, and I was silly enough to do it the
That's
wrong way
okay.
around. So, how are you today?
Yeah. Hi, Julian. I'm very well. Thanks for having me. It's a pleasure.
No, pleasure. So you a product manager for MSK Serverless. I know it was. We'll get on to what MSK Serverless is, but yeah, if you don't mind, just briefly, how long have you been at AWS, and what cool stuff have you been doing, and what brought you to the world of Kafka?
Yeah. So I've been with Amazon for a total of 5 years. I started with on their consumer side, but then wanted to sort of like, see what cloud computing is all about. I don't have a background in software, but sure, the value proposition and the way it was growing sounded pretty exciting. So I ended up looking for roles and actually, in fact, joined the Lambda team initially for briefly about a year. So I was with the serverless application repo team there,
Oh, cool.
and then I was helping customers build serverless applications and share them and distribute them with other people and other AWS customers, and did that for about a year, and then. I think I felt that I wanted to do something different, and didn't want to go too far away from serverless as well. So the Kafka opportunity came along. It was something which was growing pretty quickly. Real time streaming as well as event driven architectures were becoming pretty prevalent, and Kafka seemed to be in the right spot where it was helping. Where it had the right level of enterprise adoption, but at the same time was sort of helping customers and helping developers re-architect their applications to more of a modern stack. And then MSK Serverless was something which was pretty exciting as well because it combined the Kafka world with sort of the same principles that we espoused in the serverless world, which was elimination of overhead, etc. So I've been doing that for the past couple of years now. So in total, I think I've been with Amazon 5 years, three of which have been with AWS. Um, Split across Kafka and the pure Lambda world.
Oh, fantastic. I love hearing the stories of how people get to do what they're doing. We're going to be
Yeah.
back with the summary in literally a few minutes, but just looking back over the past week of serverless. Last week, we were looking at the SAM team, the serverless application model team, and Carl and Alex, another Wood. Sorry, Ben wasn't actually there. Apologies for the wrong name in the slide. It was me hosting it, but yeah, really simple way to be able to connect two resources together. There's a new connector resource in SAM. Just specify read and write permissions, and whatever the resource needs, Sam is going to sort you out. So it makes it much simpler to do permissioning. Yes, you can use also permissions with built-in policy templates, but those only cover certain services. These cover a lot broader services and just makes it much simpler. So yeah, and a really good demo by Alex as well. So have a look. That's on the Serverless Land YouTube channel, youtube.com/serverlessland, and that'll have this last week's and all other Serverless Office Hours episodes. So what's new in AWS Serverless? Not so much new coming, but literally in the last few weeks, I've got a little bit of visibility. Then there's this little thing called reInvent coming up, and there's a huge amount of stuff coming down the pipe. Just the two top ones, just to, if we are talking about data streaming, Kinesis, you can inspect data records in the AWS Management Console, which I think is pretty cool. And super excitement about SNS. SNS has got this really cool data protection feature. So PII information and kind of stuff, you can literally redact it as it gets sent to SNS, or SNS sends it on somewhere else. Super cool to be able to do that. And there's some more functionality with that. So that's what's new. And it's now generally available. In terms of compute blog posts coming out, yeah, the second one I'll just pick up first. If you are heading to reInvent, this is all the serverless and application integration sessions. Those are the two different tracks which are involved primarily with serverless, and that's everything going on with them at reInvent. And then also Luca Mezzalira, who's one of the world's proper gurus on doing front-end architectures, a really super guy, and he's starting this blog series on server-side rendering micro front-ends. So we talk about microservices for the back end. This is now talking about how to do some similar concepty things. I don't want to mash up his words on the front end. So yeah, that's serverless blogs. Plenty more going to be coming out. Of course, for reInvent, this is the 28th of November to the December the 2nd. I will be there with a whole bunch of other people, hoping to teach you as much about serverless as we can. There are still tickets available to register, so reinvent.aws events.com. But don't feel as if you can't join us. That would be obviously fantastic, and please also come and say hi. I would love to meet you. But if you can't, there are going to be plenty of options to watch things remotely. All the breakout sessions are recorded, so that's going to be available. And there are going to be some super fun and other interesting things that you can take part with reInvent if you're not able to be there yourself. But the topic of this week is talking about serverless and MSK and Kafka and all kind of things. We've had a quick intro from Osama, but yeah, over to you. Tell us a bit more about MSK Serverless.
Yeah, so I'll start with MSK and Kafka a little bit, if just to set the background, and then we'll have a small slide deck as well about MSK Serverless. We'll dive deeper into it. So MSK, I don't know how many people are familiar, but it's one of the AWS services. It offers a managed service for Apache Kafka, which is, some of you may know, is an open source software that helps process data in real time. Being produced at extremely high throughputs and at extremely low latencies. So, and it enables use cases such as real-time analytics, which is becoming increasingly important in the big data world, as well as some other patterns such as, event-driven architectures, because even though Kafka is built for high throughput, low latency workloads, it can also support sort of event-driven workloads. So we see customers using it for event-driven purposes as well. And Kafka, while, great in terms of what it does, it is difficult to run it yourself in a highly available distributed environment such as the cloud. And a lot of our AWS's customers had been asking the Kinesis service actually to help develop them or help them run Kafka, because there are close parallels between the two services. And that's how MSK came about, where we listen to you just as we do at AWS and develop the service. But lo and behold, we didn't stop there. As customers started using MSK, they started realizing what was missing. They started giving us feedback, or they started figuring out ways of how they can do it even better, or in a different way. So that is where a lot of our customers who are new to streaming or new to Kafka or new to event-driven architectures, but did not want to either develop Kafka expertise because it's expensive to develop or hire, or did not want to sort of bear the operational overhead that comes with the increased flexibility and configurability that MSK offers with its broker-based model, had been asking us for key capabilities such as auto scaling. So when your workload scale, does your cluster sort of automatically adjust to provide the required capacity? Or there's a concept of partitions in Kafka where data is partitioned into individual bin logs. And these bin logs are then placed on these broker nodes that you have in a cluster. And rebalancing of partitions is an extremely important activity, either in case of when one of your applications is running hot, it can create heat imbalances within the cluster, or if you're scaling your cluster, in that case, again, you need to move your bin logs around to make sure that your Kafka applications are not overloading the cluster in one particular way or the other. So partition rebalancing is also an important pain point or important activity the customers need to do. And with MSK, we give you the tools to do it, or rather MSK Provision, we give you the tools to do it. But some customers didn't want that control, and they were like, hey, take it off our hands and do it to yourself. And we just want the end product. And then the last thing was obviously cost effectiveness, because in any provision model, as you know, while it's great to sort of have that excess capacity, some customers just don't want to precisely manage the capacity for cost effectiveness or for scale. And as a result, a lot of customers were saying, hey, is there a model where we just don't have to pay for that excess capacity? So when we looked at all those needs in sort of, conjunction, and we said, okay, what is it? How is it that we can solve these customer problems and potentially do it with one swing of the axe? And maybe not the best analogy, but yeah, one swing of the wand maybe. And that's where MSK Serverless sort of started taking shape in our minds, in our thought as well. And as we dug deeper into it and spoke to customers, we realized that this is a good investment, and this is a good sort of opportunity to help customers solve their problems in the Kafka space, using some of the first principles that AWS had learned, by offering services higher level abstractions of services, such as, if you think about parallels in this world, it would be a sort of Lambda over EC2 or Fargate over EC2 and things like those, where customers start in one place and then sort of, migrate to a higher abstraction service to eliminate overhead, operational overhead, get better at sort of, paying for use, etc. So over the course of this slide deck, I'll just quickly go into sort of some details into MSK Serverless, of what it is, how it helps you solve certain problems. So I'm going to try and share my screen. Hopefully this will go smoothly. Let me see if you can see. Julian, help me.
Sorry, Tony joined me from.
Yeah.
Tony joined us from. Just to say, there's a big difference in volume between Osama and myself. I've been playing with mics. You can see the background is fried as well. So who knows what's going on with these browsers?
Okay.
Internet applications, what you can do. So
am I too loud or too soft?
No, I think I'm too loud. So yeah, if anyone's telling me we sound all right to each other, but so it's obviously coming out weirdly on the screen. But yeah, as you can see, this is all live. So please send us your questions, send us your comments, and yeah, Isam, if you can get your screen up and send me your comments, and we'll try asynchronously to try sort out this volume thing. Internet.
Yeah, you should be seeing a PowerPoint slide now called MSK Serverless.
No,
Julian, not yet. Let me try again. Okay. Maybe this time. Oh yeah, it should now, hopefully.
There we go. Yeah, it's just it's got all the. There we go. We are ready to rumble. I'll add it to the screen. Yeah, perfect.
Cool. So yeah, this is a quick sort of high level overview of MSK Serverless. I'm happy to take questions as we go, or I'm sure there'll be plenty of time towards the end as well for me to answer any questions if there are any. So Amazon MSK Serverless is a cluster type for Amazon MSK, which makes it easy for you to run Apache Kafka applications without having to manage and or scale cluster capacity. So if you think about the traditional Kafka model, you would go and provision a bunch of broker instances, which would sit on EC2 nodes, or if you're managing it yourself, maybe EKS spots, and you'd have to define, how much capacity to allocate to each broker, how many brokers to have, and how much storage volumes to have. But the funny thing is, customers, when they think about their data problems, they don't think in terms of compute capacity or memory or storage necessarily. They think about how much data I'm gonna, process or I'm gonna send through this. So from that point of view, it does require some working backwards and some kind of mapping between how much data you want to process and how much compute capacity you should have, or how much storage capacity you should have. What MSK Serverless does is that it takes all that away from you, and it says, hey, you just send data, we'll take care of provisioning and scaling capacity as a server-side capability. Now, what that means is that we automatically provision and scale compute and storage resources. So compute and storage resources don't go away, even though it's called serverless. But yeah, we do that on your behalf. So you can use sort of Apache Kafka in an on-demand fashion. And then most importantly, you pay for the data you stream and retain. So your total cost moves in closed lockstep with the amount of data that you're processing. That's a quick overview. Let's take a look at some of the key benefits that MSK Serverless as a result provides. So first of all, it's extremely simple to use. Getting started with it is a matter of few clicks in the console. And what makes it even easier is that you can use any existing applications that you may be using with Kafka today, or any of the existing tools that exist in the Kafka ecosystem today with MSK Serverless. So because under the hood, we provide open source Apache Kafka, we have not taken that capability away, even though we've provided an abstraction on top of it, so that customers can get started with it very easily without having to refactor a bunch of applications or rewrite a bunch of code. It lowers operational overhead, goes without saying. Obviously, you can end up spending hundreds, if not thousands of engineering hours every month, and those engineering hours can then be repurposed to solving your customer problems. You don't have to train your workforce continuously to be in lockstep with Kafka changes or Kafka evolution, and as a result, if you're not in the business of managing Kafka, you don't need to be.
Yeah, I mean, I think that's one of You know, the big thing specifically with these open source tools, I mean, they are so powerful and they're so ubiquitous. And, you know,
Yeah,
Kafka is one of them. It's just so used in so many enterprises. But enterprises just don't want to have to look after that. But they want to use the open source model. They want to
right.
integrate it with the rest of AWS. I've been doing a lot of work recently, which I'm going to be talking about in a reInvent talk about how Lambda connects to things like Kinesis, but Kafka and self-managed Kafka as well, and MSK Serverless. And it's just such a powerful thing to be able to just so easily hook Lambda up to these services. And when you don't have to look after the clusters yourself, you know, absolute winner in my book. So yeah, best of both worlds. You get your
Yeah.
open source love, and you can get Lambda integrations, which I know we'll talk about. And yeah, I think it's fantastic.
Yeah, I mean, I think you touched on a great point there, Julian. I think a lot of customers, even though there are multiple Kafka solutions available in the market today, they tend to prefer MSK because of that integration with other AWS services. So as you pointed out quickly, we have Lambda integration available. We have other direct integrations with a couple of other services as well. And then we have more coming down the pike, which would help just moving your data around for whatever purpose you want, be it, AI/ML, be it warehousing, be it databases, etc. So all that connectivity, the connective tissue that AWS takes care of, enhances the value of using MSK. In addition to the fact that you're still using AWS, you're still using open source, which I know customers prefer for a variety of reasons. And then, yeah, I think what this does is that it makes it cost effective, especially for highly variable workloads. So yes, there is a world where provisioned will be more economical for some use cases where you can predict your capacity very accurately or precisely, or you don't have to move your capacity around because your workload is pretty predictable in terms of traffic patterns. But in practice, a lot of customers either don't want to do the former, or workloads don't really tend to stick to a pattern, which is predictable. And as a result, what you have are these variable workload patterns, either diurnal workload patterns which move with the sun, or maybe you have dev test workloads, or you have certain types of applications that only require capacity at certain times during the day, and to address those or accommodate those in a consistent sort of capacity manner means that you're not running your applications cost effectively, which then makes serverless all the more important, because you don't have to worry about paying for that sort of excess capacity at all times. You run it in a cost effective fashion, especially for highly variable workloads. So yeah, that means that it's best suited for certain types of use cases. So first one that I'll focus is if you're new to Kafka, or maybe you're new to streaming and you haven't used Kafka before, and you don't want to be in the business of predicting capacity. As I said, right, you think about, oh, I have a workload that produces, I don't know, 1 terabyte of data every day. I need to process it. How much compute do I need? How much storage do I need? You don't need to do that. So if you're new to Kafka, MSK Serverless is extremely easy to get started. And then as a result, because it's offering open source Kafka, let's say 3 months down the line, 6 months down the line, you realize that you can use MSK provisioned, and that's more cost effective. You can simply switch over. So that option remains. So if you're new to Kafka, starting with MSK Serverless is a no-brainer. And then, you can make that decision along the way as you go along. It obviously, if you're not particularly keen on configuring your cluster to the nth degree, and you're like, okay, I just need to tweak a few things that I want to retain control over. The rest, I'm happy to give the service control of, because they know what they're doing best. And if you're that kind of a customer, then yes, less configurability, then MSK Serverless is also very suitable for you. And then last but not least, I've already touched upon that. If you have a spiky workload, or if you have a variable workload where traffic changes, quite a bit, either during the day or during the week, then again, MSK Serverless will be a good fit for you. Some of the key features that we offer. So we offer on-demand streaming capacity. So you get up to 200 Mbps of write capacity per cluster. This is per cluster basis. So you can send up to from between 0 and 200 Mbps of data at any point in time. And you can read up to 400 Mbps of data at any point in time. So it's almost like, if you do the math roughly, it's 2x the fan out. But obviously, you can be doing more writes at a given point in time and less reads or whatever, or you could be doing both at the same time, and you can read twice the data as you write. at any given point in time. So this allows you to have multiple consumers for the same data and fan out your data if you need to. We also allocate some capacity on a per partition level. So if you're familiar with the concept of partitions in Kafka, you have these bin logs, which data gets written to and then consumed from. So to make sure that each partition can support some amount of reads and writes at all times, we allocate certain capacity to avoid the noisy neighbor problem. But these limits are pretty generous, so it's not like you will be constraining your partition or your consumer from being able to read from a given partition. It's just there as a protection to make sure that no one partition takes up all the capacity in a cluster. We offer throughput-based pricing. So just a quick dive into pricing. There is some per hour cost. There's a cluster per hour cost, and the way to think about it and rationalize it is, if you think about the electric power company that provides electricity to your house, you switch on and switch off and you pay for use, but then there is some fixed overhead which allows the electric company to provide those lines and those connectivity from your house to the power station. Think of MSK Serverless the same way. We do have to have some capacity available to scale up instantly and to avoid the so-called cold start problem with Kafka, because with real time and like Kafka supports real time analytics, and you can't be real time if you have some latency in terms of starting up. So there is a fixed charge per hour, but then outside of that, everything else is pay per use. So you have a cost per data in. So if you're writing data, you're paying some amount for that. If you're consuming data, you're paying some amount per GB for that. If you're storing data for 1 day, you pay only for 1 day. If you're storing it for 2 days, you pay for store. So it's sort of like per GB month. And then there's a cost for maintaining these partitions. But this is completely within your control. So if you reduce the number of partitions, it comes down. If you increase the number of partitions, it goes up. So from that point of view, it's throughput-based pricing and completely in control, other than a small base cost. But then if you scale up your cost, even if you scale up your workload even to 5 Mbps, the cluster per hour cost, you'll see it become like a very small component, like a very small overhead in terms of your overall cost. So that's how the pricing is.
So I know just to jump in, I know some serverless purists are always going to go, oh, it doesn't scale to 0, this kind of thing. But I suppose you're indexing on the things that you really can control. I mean, the point of some of these managed services like Kafka is you're not reinventing Kafka. You're using the same Kafka that people are using on-prem or in any other environments, and so you can't re-architect Kafka that it can completely scale down to 0.
Exactly.
So is there a way that people can turn off their clusters if they're not using it for dev or test on the weekend or this kind of thing? Or is there a way that for non-production workloads that can potentially scale some things down? Or what would you say to customers who are thinking about that?
Yeah, I mean, I think unfortunately Kafka doesn't allow right now. It doesn't decouple storage from compute. Yeah. So if you were to turn off your cluster, then any sort of state that you're maintaining in the cluster goes away. And as a result, if you want to preserve the state for now, then we would recommend keeping the cluster on. There is a world where if you don't care about state, or let's say if your retention is only, and it's not just data, it's also metadata. So if they have topics and partitions and sort of configurations in it, it'll also go away. But if you have a standard pattern and you don't if you have all automation built in terms of creating topics, etc., then for dev test workloads or for sort of workloads that are not production ready necessarily, you can potentially turn off your cluster, then create a new cluster, because creating a cluster is a matter of minutes. Like it's like takes 3 minutes, 4 minutes, and we'll show that in the demo as well. But so there is an element of not being able to scale to 0. That's why I was caveating that a little bit, preempting that question. But I think the way to think about it is that the reason why it's not there is because of the fact that your cluster does maintain state, and state in Kafka is not decoupled from compute, unfortunately, not yet. So as a result, there is some base costs.
No, thanks for that. And I also think that there just are some things that are going to need to have a steady state. That's just the way they work. I know some development teams will have in a development environment may have a singles shared MSK cluster, for example. And I've even heard people doing clever kind of things where they allocate different partitions to different developers so they can sort of independently do their own kind of thing and do that kind of stuff. So yeah, that's one option, having a shared thing. But yeah, I actually really like the idea. If it's so simple to set up and tear down, that literally you could just do a sort of a MSK deploy when you need it, and you're going to do your testing, because sometimes people are only going to test these things, a few days a month or that kind of thing. So
Exactly. So that way it is. So, but yeah, if even for production workloads, especially if you think about, as I said, if your workload scales past a few single-digit Mbps, then the cluster cost becomes very negligible. So, unless you have a workload that scales to 0 and stays there for a majority of time, I think you'll see that your TCO is a large percentage of that is coming from variable dimensions as opposed to fixed dimensions.
Cool. Thanks.
Cool. So and then we talked about partition placement briefly. We also offer automatic partition placement. So whether it's in response to a scaling event that we do in the background, or in response to a particular application suddenly starting to send more data than it was, and any sort of partition management that needs to happen to keep your cluster well balanced and sort of the heat spread across the cluster evenly. The service team monitors that proactively and then addresses that if it needs to be in a seamless fashion where your applications don't experience any sort of changes or any sort of effect on performance with this placement. So I think we're taking a much more careful approach, much more conservative approach, where we are at times even over provisioning to make sure that till we get to a stage where partition placement is completely, basically safely doable at all capacity levels. We're taking that approach, but then the capability is certainly there for us to be able to auto partition placement or auto manage partitions as and when needed. One of the key things that our customers told us when we were developing this is that they care about compatibility with Kafka. So we offer open source Kafka under the hood. It's just an abstraction layer on top of it. As a result, if you have client applications today, or if you want to build client applications that you can use with any sort of Kafka, then doing this for MSK Serverless will not be wasted effort because they remain fully compatible. So that means that if you need to port over your applications tomorrow or port in your applications without a lot of overhead, then the compatibility aspect of the service helps you do that without taking on a bunch of extra work. And we'll quickly demo that as well towards the end of our presentation. It offers the same security level as MSK, so a lot of customers do care about that as well, because MSK is behind a VPC, and a lot of customers when it comes to data handling care about security. So I'll quickly share about how we maintain that. So we have whenever you create a serverless cluster, we create the resources inside a service-controlled VPC, which is the box at the top of your screen, and then you place your client instances, which are these sort of orange boxes, inside your own VPC, and then we create the private link connectivity between the service VPC and your VPC to make sure that traffic traverses smoothly over a private connection between your clients and the cluster, and vice versa. And then that's on a network path, but then we also enforce encryption both in transit as well as at rest. And then your applications are required to authenticate using IAM. So your applications can assume an IAM role, and you can have a policy, which IAM policy that determines which client has access to which type of data within your cluster. So you can set permissions in a fine-grained way, where you say only certain this client has access to only this topic, and that too only for reads and not writes. So things like those. So you can get fine-grained about how you grant permissions to your clients, and as a result, you have a way to secure your cluster even further with IAM policies. And then, we maintain same high availability. So because it's sort of, these are production systems, or we say these are production ready systems, we ensure that they're highly available. And how we do that is by, we require you to define at least 2 subnets when you're creating a cluster. And what we do is that you can define more within your VPC, but then what we do is that we drop network interfaces in at least 2 subnets, so that, if and when there is an availability zone outage or something, your clients can fail over to an alternative subnet, which is in another availability zone, and maintain connectivity with your cluster without having to sort of, recreate or modify your cluster necessarily. Best practices is to define more than 2 subnets, but at least 2 is what we mandate to make sure that there is at least an option in case of an availability zone outage for your client to keep communicating with the cluster. So yeah, that brings me to the end of this just quick high-level overview. I don't want to just talk. I want to show as well. So I'll move to sort of a cluster creation demo quickly. So if we Julian, let me know if you can see my
slides coming up.
Okay.
Not your slides, your screen coming up. If it adds. There we go. There it adds. Just one thing on the cluster. Obviously, there's no additional charge for scaling out MSK Serverless to additional availability zones. You're just attaching it to your own consumers in your own additional availability zones.
Right. So what you do basically, the way it works is that, and I'll show that in the create cluster flow as well, is that we just ask you to say, hey, these are the 2 or 3 or 5 availability zones I want to configure with my cluster. The configuration is now at no additional cost, and you can attach up to 5 VPCs with a given cluster. What that means is that you're defining 5 VPCs that have connectivity, have a network path from your VPC to the cluster, and then you can place clients wherever in those VPCs and whatever subnets that you have configured, and have whatever failover path, configurations that you have. So that way, there's no additional cost. It's basically the client side is something that you completely control. We just drop these network interfaces and these subnets and VPCs that you define at no additional cost. As I said, up to 5, and then each of these 5 VPCs can support as many subnets as AWS offers within that region. Got it. So yeah, so this is just the MSK console. You navigate to it through the AWS console. If you drop services under analytics, you'll find MSK. I'm already here. So as you see, this is sort of your landing page. And one of the things that we prioritized when we developed this feature was that we wanted to keep the console and the control plane operations, so the API experience, uniform. So you can use the same API as you've done historically with MSK to create a serverless cluster instead. So there's no difference in terms of how you would manage your clusters. So yeah, you would, as you can see, I have 2 clusters already, both provisioned and serverless. They're in the same sort of interface. And as this quick demo will be sort of an exercise in creating a cluster. So you click this orange button to the right of your screen called Create Cluster. There are 2 ways to do it: Quick Create and Custom Create. Quick Create will basically pre-populate almost all the fields, but since we are sort of taking a look at how to go through this process, we'll click Custom Create. Next step is to define a cluster, put a cluster name. So let's just call it MSK Serverless Demo. I already have a demo cluster, so I'll just name it Demo 2. And then this is the cluster type. So as I talked, we have a serverless cluster type and a provision cluster type. A provision would require you to then go and define the number of brokers, pick a Kafka version, pick the storage volume. So it's very great. It's great if you want to have control over all these aspects. But since we're talking about MSK Serverless, we'll keep it serverless. It tells you sort of the same things that we talked about. You have a write throughput, a maximum of 200 megabytes per second, read throughput, maximum storage per partition. So it gives you a view of some of the constraints of the system. And then once you've gone through it, you click next. This is the VPC part that I was talking about, Julian. So you can select your VPC from a drop down here, all the VPCs in the same region in your account. Let's say we pick this, and then you have the option of defining subnets. So because I'm in US West 2 right now, or beg your pardon, US East 2, it shows me all the available subnets within the US East, or rather availability zones within which there are subnets available. So I can choose any of these. So I choose the US East 2A zone and a subnet here, and then let's say 2B here and a subnet here. And this is the part I was talking about where you're required to provide at least 2 subnets for high availability. And then you can define your custom security groups or choose your default security groups. the security group basically acts as a firewall for your instance to control inbound and outbound traffic, and you can choose up to 5 security groups again. And then you can repeat this process for other VPCs. So if you have clients spread across multiple VPCs within your account, you can add VPC configuration. We're also, just a sneak peek, adding capabilities to potentially connect clients from different accounts as well. So that will also get added here, where if you have clients spread across multiple AWS, if you have a multi-AWS account set up, then that will also help. And once you've done that, you click next. Right now, you only have one access control method, which, as I said, is IAM. In future, we may have multiple, and then over there, you'll have an option of choosing it. But since it's only IAM right now, it just tells you that it's IAM, and you go next. There's some metrics that you get by default, which are published to CloudWatch as part of your cluster at no additional cost, and then you can add tags here. So let's say if you want to say, hey, this is my team, and this is Kafka team, so something like that, or Kafka admin team or something. So you can add these tags and then click next, and this is sort of like the review page, where it just tells you like the name, the networking setup that you have, and then tags that you've enabled, and then you hit create cluster. So it says that a typical cluster takes up to 5 minutes. It's usually less than that, but yeah, it can take up to 5 minutes, but sort of that's what the extent of it is. And then click create cluster, and then sort of go and start creating cluster. In typical sort of cooking show fashion, I have a cluster created, so we'll use that for the purposes of this demo. Next step that I want to show is time permitting. Do we have time for a quick produce consume demo?
Yeah, let's
Julian?
go for it. Yeah, we've got 20 minutes. So.
Yeah, all right. So what I want to show today in the demo is that, I have 2 clusters, as I said. One is a provisioned cluster, which is here, and then there's a serverless demo cluster, which is active already. And I want to highlight the compatibility aspect of it as well. So what I'll do is that I'll first produce data and consume data from a provisioned cluster, and I'll use the same client. And just by changing the connection string to the serverless cluster, I will just show that you can use the same Kafka tool, which is a console producer and consumer, to produce data to a serverless cluster just by changing that string and nothing else on the application side. So so here I have a Cloud9 environment, which is AWS's integrated development environment. I have 2 instances open side by side. One is one I'll use as a producer instance, and the other on the right side I'll use as a consumer instance. So what I have is I've already SSH into an instance that's configured to produce data into a Kafka cluster. If you want to learn more how to do that, we have our developer guide that sort of lists out step-by-step actions of how to configure either an EC2 instance or a container instance to produce data to Kafka or consume data from Kafka. This one already does that. What I'll do first is I'll take the bootstrap broker string. Now, bootstrap broker string in Kafka is this connection string that you have with the cluster. So I'll go into the provision cluster detail page. There's a button here called View Client Information. You click on it. It tells you the endpoint that you can use to connect with the cluster. It's a rather long one, but basically these are like endpoints for at least 3 brokers that we provide, so that the client can connect with any broker available at any given point in time. You copy that connection string, and over here, what I'll do is that I'll set the environment variable called bootstrap broker string, BS for short, with this string. And then we'll quickly check this as well. So it's set there. So what this will do is allow us to then run certain commands. So I have these in a notepad here, certain commands. So to create a topic first. So I'll go ahead and create a topic next in your cluster. So this is a standard Kafka command for creating topics. It says Kafka topics. The bootstrap broker string is right here, encoded. And then, the topic name is MSK Serverless Tutorial 2 here. And then we are creating 6 partitions. As a default, you can create 1 or 2 or whatever, however many you want. And then you click here, and so it just says, it confirms that it has created a topic called MSK Serverless Tutorial 2. What I'll do in parallel is I'll start a Kafka console producer here. So that's the next command, which is this one. So the Kafka console producer is a desktop based tool, or it's a tool that you can use to quickly produce data to a topic, and then inspect it using a Kafka console consumer. And it helps for just quickly testing your cluster. Your typical application would be definitely would encode the producer API, but yeah, this one is just a desktop tool. So again, this is producing data. So what it'll do is that it'll enter me into a production mode. So now you see this sort of cursor here, and I can type a message and it'll produce data. So to show that it's actually producing data, what I'll do in parallel is that I'll start a console consumer on the other instance, and I'll configure that consumer to consume from this data, or from this topic, beg your pardon. So as you can see, this is Kafka console consumer, and it's consuming from this topic called MSK Serverless tutorial. And there's also one configuration which says from beginning, but since it's a new, so you can configure it to read from the beginning or from the middle or from the end. But since they've just created a topic, we'll read it from the beginning. So right now, obviously, since there's nothing in the topic, it's showing nothing. But hopefully this will work as I type through some of these messages. So yeah, so as you can see, the real-time nature of this as well. So on the one side, my client is producing data to a given topic, and almost in real time, near real time, you're seeing this data come through on the other side. But again, this was a quick demo on the production side, and you're like, we're not here to see a demo for MSK provision. So now what we'll do is that I'll just simply go back to the MSK console. I'll go to the serverless cluster detail page. I'll pick its own client information. So the bootstrap string, as you might notice, some of you, is that it's different from the bootstrap string from the provision clusters, because the brokers are completely abstracted away behind this one unified URL. And what I'll do is that I'll go back and I'll just set the bootstrap broker string to this one now. And I'll double check that this is indeed done. And I'll do the same thing here to make sure that both of these instances are communicating with this new cluster now. And I'll just repeat the steps now. So I'll go and create a topic in this. Pardon. So yeah, I'll just create a topic, the same topic called MSK Serverless Tutorial 2 here. And the same command, as you see, it works here. And I'll start a Kafka console producer. So now it will enter into production mode, and I'll just, do the same thing on the consumer side, where I'll start a Kafka console consumer here, and it will go into consumption mode, and then, serverless hopefully works just as provisioned. Yeah, it does. So yeah, so quickly, so what I've demonstrated quickly here is that we went through and produced serverless, or produced data to a provision cluster first, and just by changing the bootstrap broker string on your client to now point towards a serverless cluster, we were able to produce data and consume data without refactoring anything. So the same role that the producer and the consumer did in this demo, your client applications will do by using the producer API of Kafka and the consumer API of Kafka, or any other tools that you're using will do that. And all you'll need to do is just change the configuration of the bootstrap string. So yeah, that was the quick demo. I'll pause here. I think I'm done with my side of things. I'm happy to sort of take questions at this point. I'll stop sharing as well.
No, perfect. Yeah, I
yeah.
like, in fact, the simplicity of it, that using one or the other makes no difference, and you just using a different endpoint to connect to. Can you talk us through some of the sort of upgrade things, and that's in terms of doing maintenance and everything? I know it's serverless, but I know Kafka, and people are used to, and some other event brokers, people are used to doing a maintenance task that happens sometimes every week. So that's the one question. And then also version upgrades. How would you handle that?
So a great question. So I think Kafka version. So there are two things. Let me first answer the question about Kafka version. So as a community is pretty active, and Kafka as a project keeps coming out with new versions almost at a pretty decent cadence. So I think they release a major version every quarter, with improvements, with new features, and sometimes it's just bug fixes, etc. What we do in the provision world, you have the option of choosing the version. In the serverless world, we pick the version that we feel works best. And the reason why we want to retain control of that in MSK Serverless is because the Kafka version inherently only affects the cluster operation and not the client side. In the Kafka world, the client compatibility with any Kafka version, at least they guarantee backwards and forwards compatibility. We also test extensively which versions work with any given version, and we want to, but when we launched, we said that any version after Kafka 2.2.1 on the client side will work with whatever version MSK Serverless is running under the hood, and we will maintain that promise. So version upgrades, customers don't need to worry about it. They can choose to upgrade their clients whenever they want, as long as they are a client version later than 2.2.1. It should work seamlessly with whatever version the MSK Serverless service chooses to run for its own sort of instances under its control. And then what that does, it takes the overhead away from sort of having to do version upgrades or staying in sync with what Kafka is offering. And then on the maintenance side, which is in MSK world, even though it's not something that customers do themselves, but in MSK provision, we maintain, or we have a maintenance activity that runs on every cluster once a month at least, and that is to apply any sort of security patches. We patch EC2 instances that run these broker nodes and make sure that the cluster is healthy. And even though if your cluster is architected for high availability, your clients will not face any outage. It is an activity that is not completely transparent to the customer, and we don't want it to be transparent because your clients may see some degraded performance because one broker at a time will not be available. In MSK Serverless, that thing is completely transparent again, because we run these huge backend fleets, etc. So we are able to sort of accommodate customer traffic, even if a maintenance activity is going on without any degradation in performance or without any effect on the performance of your clients. So that's another difference where the maintenance activity does happen. Of course, we have to abide by the AWS best practices on security, and security is always priority 0 for AWS, but that activity is transparent to the customer.
Yeah, that's super useful. I mean, I think of all the downtime things for managing Kafka and doing the version upgrades as well. To have that all abstracted behind a single API endpoint is excellent. So yeah, just to reiterate, if you go MSK Serverless, no longer need to worry about version upgrades. You no need to worry about managing your fleet and bringing up to new EC2 instances in a new availability zone and decommissioning the other ones. Just handled all for you.
Yeah.
Cool. And then question I was thinking about the sort of VPC access. So MSK Serverless is running in a service VPC as part of your VPC, and then your consumers then are running in whatever VPC as the customer.
As a customer,
and,
yeah.
And I suppose you're using, similar to Lambda, I suppose in a way, an ENI connection that you need to then manage. That you then provision within the account, or
yeah, so we provision a VPC endpoints. So these are issued by the AWS Private Link Service, as some of you might know. So yeah, we provision VPC endpoints. These are fully managed VPC endpoints that do not show up in your account. They do not show up as a cost line item on your bill. These are included in the service cost at no additional charge. And we manage the life cycle of those endpoints for you. What obviously you have control over is who has access to these endpoints, and which subnets do we want to create these endpoints in, and then you can set your own security groups on these endpoints as well to make sure that there's further, there's an additional layer of security on top of the network part itself. So yeah, these are fully managed, and the connectivity is maintained through these private endpoints, and then we have a VPC endpoint corresponding VPC endpoint service. That's the actual endpoint that your clients would hit, but it's the mapping of the VPC endpoint to the VPC endpoint service, and then further on to your actual backend Kafka is all maintained by the service team.
Okay. And I know this is maybe heading a bit into the weeds, but do you then run and maintain individual EC2 instances and clusters per customer or per account? Or is this just a large fleet that you can then magically serverlessly, be able to
Yeah.
run individual, multiple customer workloads in a sort of multi-tenant but secure way?
Yeah, it's the latter. Naturally, to make best use of the infrastructure and pass on that value to the customers in terms of not having to pay for idle capacity, we run a large, we actually run large Kafka clusters in the background, and then we provide sort of allocated capacity on a per MSK serverless cluster level to our customers in a as you rightly described multi-tenant yet secure way. Yeah.
Okay. Oh no, that's brilliant. I mean, that's when I'm thinking MSK serverless is not just, in fact, the consumption of it, but from a customer perspective, that you're not worrying about the servers in the back end, but you're managing the servers is a far bigger thing than just pretending these are individual clusters of servers in the back end. So, yeah,
Right. And that's
MSK
actually
serverless itself.
yeah, yeah. Yeah, that's actually what also introduces certain constraints. So a lot of customers have asked us about this, that, why do you have certain constraints on throughput or on XYZ dimensions? And part of it is, yeah, it's still a newish service, and we are going to iterate and get be able to offer larger workloads, etc. on this. But for now, there's certain constraints in the system within which we need to operate and master. So I think that's what drives some of the constraints. But as you rightly pointed out, Julian, it's not just that the consumption layer is abstracted away. It's the actual underlying capacity is also being managed.
Okay. And then, yeah, just talking about obviously being serverless office hours and the Lambda integration. I mean, this seems like the whole way Lambda connects with all the Kafkas, including MSK Serverless, is just via an event source mapping. And you've got some particularly cool configuration things that you can do on the event source mapping itself. Things like filtering and batching and windows and all that kind of thing. Yeah, do you want to just chat about that connectivity?
Yeah. So we work very closely with the Lambda team, we make sure that we provide feedback to the Lambda team from our customers, and obviously Lambda gets to speak with the customers who are using the event source mapping. But that consumption pattern is getting very popular. It's still in its early days, because I think the integration has been around for about a year or so. But just as customers love to use Lambda with Kinesis or SNS or SQS. This is similar, where you can set up an event source mapping, which will then map to one of the topics in your cluster, and then as data gets written into these topics, Lambda will automatically pull that data and make it available to your own function for whatever processing you want to do. As you said, filtering is a native option within Lambda now for MSK, as well as some of the other services. You can send it to S3. You can discard certain data. You can process it quick, real time, transform it, what have you. And the best part about Lambda is that it scales automatically as well, so you don't have to worry about scaling your consumer. So if you're using MSK Serverless with Lambda, you actually get a pretty end-to-end serverless experience as well. And then it works seamlessly with both MSK Provision and MSK Serverless, as you pointed out. So if you're looking to transition between one or the other, you don't have to worry about moving your entire consumer or client application as well. You can just create a new event source mapping and just connect that with your existing Lambda function.
Yeah, no, definitely. The whole Lambda way it integrates runs a whole polling fleet in the background to be able to pull things from MSK and all the other event sources. That is one of the most powerful things of Lambda. And the people who use it are like, oh my word, this is so much simpler. You don't have EC2 instances or containers even to spin up as consumers. It's just part of the service. We actually have a question who's coming. Claudia CD, thanks for joining us via YouTube. Yeah, this may be a bit generic, but any blogs or tutorials that you can think of off the top of your head to set up monitoring of MSK with Prometheus and Grafana? And then that's a bit specific with those tools, but world here.
So just a caveat, MSK Serverless doesn't integrate with Prometheus and Grafana yet, okay, but MSK Provision does. I don't know if there's a specific tutorial, but we do have workshop labs, etc., that customers can go through, which sort of like walks them through step by step. So it is actually a tutorial, but yeah, we call it labs. So I don't know if I can drop a link here or something, but yeah, those are helpful that customers can use to sort of set up Prometheus on their end and
Yeah, you can
Okay,
send a link in the chat and I can post it up. But then thanks,
I'll
Claudio,
I'll, I'll do that. Yeah.
for doing that. Yeah, the only other question I had while you are hunting for the link, I know it's
Yeah.
a bit unfair to be able to think and hunt for a link at the same time, but
No, that's okay.
I mean, just to circle around, any sort of gotchas or things that people should think of, or being sort of open and honest, any reasons why people should not use MSK serverless yet?
Yeah, so I think scale is the other thing. As I said, I think there is an element of, as I talked about, some of the constraints. We offer only up to 400 Mbps of read capacity, or 200 Mbps of write capacity, and 400 Mbps of read capacity per cluster. So if your individual cluster size exceeds that, and if you're unable to break your cluster into smaller workloads, then that would be something to look out for, definitely. And we would then say, hey, you might want to consider either breaking your cluster. If you can't break your cluster for whatever reason, then consider using MSK provision. We are collecting feedback. We are keeping a pulse on it. I know some customers really want to use serverless at higher throughput workloads, but right now we believe the system is not ready for that. So we are being a bit conservative about it. But yeah, eventually we do foresee offering much larger workload counts as well. Similar to that, right now we have we only support IAM as an authentication mechanism. In full transparency, we know some customers use other authentication mechanisms with Kafka in the Kafka world, because Kafka supports multiple auth types, and some customers that's a blocker. And rest assured, we are working on it. We have line of sight of when we'll be able to offer more authentication options. But yeah, once that is, so we'll add those iteratively. So as some of these become available, you'll realize that those are no longer blockers for you. But I mean, right now it might be for some customers. I think those are the two main things that I can think of. Outside of that, there might be specific things that some customers really need but are not available yet, because as I said, we have a we have a 3-year handicap compared to the MSK provision service, and then similarly, if you're self-managing Kafka on your own from before, then even probably more of a handicap. But rest assured that we are continuously investing in this space. In fact, both for MSK provision and MSK serverless, we continue to sort of pour in features and pour in capabilities so that customers get the most value out of it. So yeah, keep your pulse on the new launches, but hopefully we'll get rid of these constraints one at a time. And I just dropped a link as well for the Open Monitoring Lab.
I've put the link in. Yeah, no, really appreciate you spending the time today, Osama. I think it's great that we're having more serverless services, and the purists are going to think it's not entirely service, but if it's 99% there and it's going to help you with whatever you're doing, that's a winner. That's a winner.
I'm more than happy to take all the criticism on the chin. I don't know if I feel free to share my Twitter handle, Julian. I think it's just simply at Osama Naseem, all small caps. I'm happy to just get whatever feedback we have, and yeah.
And please,
we'd love to hear from customers.
AWS, we love to hear from customers, as Osama says. The products get built for the stuff you want. So yeah, let us know what we can do, and also we'll continue inventing on your behalf. But yeah, I just want to say thanks so much to Osama to taking us really well through Amazon MSK Serverless. For all information on everything else serverless, serverlessland.com is your one-stop shop. We've got blogs, videos, learning paths, events, serverless patterns and workflows and snippets. So lots of code that you can get started with. But yeah, Osama, thanks again for spending time with us here today. And we'll see you same time next week for another episode of Serverless Office Hours. We're getting towards reinvents. We may have some cool things to talk about. But yeah, enjoy the rest of your week, and we'll see you again soon. Thank you very much for joining us.